Okay, so we have a quiz. People have been working on it for a little over 15 minutes. You're doing pretty well, but there's one step that not everybody did. And if you don't do that step, you can't do anything. Okay. So I'll write that stuff out for each of these, then I'll work about it in a little more detail. Okay, this means I'll just use the symbols for right now. Whatever your numbers are, you write y equals that because y equals f of x. That's a usual idea. Okay, there's more to it than that. That's sufficient for right now. Okay, then you switch. And you get x equals dy minus c, whatever your d and c are. That's what you solve for y. That's always the way it's done. You switch x and y as we did with the table. And you know how to do the graph if you have a table. Well, doing the algebra is a little harder than doing the graph. You have to start the algebra out with this logical step. Okay. Again, you switched columns when you did the graph. So you switched x and y, didn't you? Okay. Well, that's the same thing you do here. You switch x and y, and then you solve for that. Y gives you your inverse function. Here. Y equals square root of x plus a, whatever a happens to be in your case. And you switch, and you get x equals the square root of y plus. And you might or might not know what to do with this. It's actually very, very simple. We haven't done that kind of a step. I think it occurs over. Okay, but it's a very simple step. So if you don't know it, you need to see it. Anyway, okay, here you're going to have y equals bx minus a over cx plus d. Complete it, so you switch x and y. You know what you switch. Then you get x equals by minus a over cy plus d. Okay. You do exactly the same thing in every situation. You just first of all write it as y equals, and then you make your x's into y's and your y's into x's. And the reason goes right back to what we did when we switched the columns of the graph to get the graph of the inverse function. Okay. Now, you know how to graph this, you know how to graph this. It's transformations. You don't really need transformation, that's just slope and intercept. That's a transformation of the square root function. And you were introduced to that in open math. I haven't introduced it because square root function is just the inverse function of the squaring function. So we switch x and y, and the y equals x squared, and solve for x to get square root of y, or y square root of x. So if you just do this with y equals x squared, you get the square root function. And if you want the graph of the square root function, you just take your table for the square root function and switch sides, and you get the graph of the square root. You should know that. So kind of store that away. We'll reinforce. Okay, so No, I'm going to use my numbers or whatever. I'm not really using my numbers, but I'm just making up numbers. They're in the right sequence, but let's take 11x minus 8. 11 1. Okay, I understand how we get that. Here, my D is 11, my C is 8. I write y equals 11x minus 8. Switch like I did here. So here's my D and C. Comes out. Yes. Okay, so that down. Add 8 to both sides. And I get x plus 8 equals 11y. Then I'll write it 11y over 11 equals x plus 8 over 11. So y equals x plus 8 over 11. Thus, F inverse law 1 there of x equals x plus 8 over 11. You want to write that stuff out to reinforce what you're doing, and so you have a formula for F inverse. Now, we check this. That's just part, that's an automatic part. So if you didn't check it, well, if you're still working on everything, you might not have time to check it. But if you had time, you should have checked. Okay? And you probably should have checked at least the first one because it's pretty easy to check. Well, F inverse of x equals I really should have written my first assumption. F of x equals 11x minus 8. Okay, so I have an F of x to actually look at when I check it. So we plug that in, we get that's what I'm with the sliding. And so we're plugging x plus 8 over 11, which is your F inverse of x, in for x, and that's what it looks like. We just got the 11, we got the minus 8, and I don't know why I wrote over 11 in the denominator. Must be doing mathematics by superstition rather than rule. So used to writing 11s in the denominator or something. Okay, so that equals then, well, 11 divided by 11 is 1. You write that as 11 over 11 times x plus 8 over 1. You got to get x plus 8 minus 8, f equals x. And then F inverse of f of x equals dot 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 equals x. And we've verified it, and I'm not filling in the details here, they're equally easy. Okay. So that's the complete solution. We verified it. If you're on a test and everything works out that way, you know you did it right. And if it doesn't work out that way, you make yourself a note. Dang, I think I did this right. If I have time, I'm going to come back and fix it, right? Since you have unlimited time, well, you do have limits of time. You testing stuff closes after that time. If you started at 8 o'clock in the morning and you're still working when the testing center closes, you're probably already falling asleep and you're probably starving. So you're probably not going to come back and do it. Okay. Hopefully you're not going to need to be there that long. You won't be, you can't force yourself to be there that long. Okay. Yeah, be prepared so you don't have to stay there a long time. Okay. There we have it. Now, for G of X. Okay, well, all right, now G of X equals square root of X plus 6, let's say. So you got Y equals the square root of X plus 6. Switch X and Y, you get X equals the square root of Y plus 6. Square both sides. You have the square root over here. If you square the square root, you're just going to get Y plus 6. You got to know what a square root is, so you know when you square root, what's going to happen. But that's something that's not too hard to understand. Make sure you really understand that. You get X squared equals square root of Y plus 6, all squared. So that X squared equals Y plus 6. So that Y equals X squared minus 6. Okay. So this is the easiest one. If you just know to square both sides, and square root disappears, you get a square on the edge, you subtract 6 from both sides. Look, it's 3 steps. Okay. So let's F inverse, that's G inverse of X equals X squared minus 6. Then G of G inverse of X equals, well, G is the square root of X plus 6, so it's the square root of G inverse of X, which is X squared minus 6 plus 6. Which is the square root of X squared, and what's the square root of X squared? Now you want to say X, but that's not really true. So there's a little complication here, but we'll kind of ignore it in this case. This equals plus or minus square root of X. Okay. If X is greater than 0, G of G inverse of X equals X. And you can do a little reasoning to see why the minus doesn't work. That's a finer point that you really want to get, but we're not going to address it right now. Okay. And then you do G inverse of G of X, and you get a similarly confirming solution. So this sort of checks. Got another check to do. That's how you work it out. Okay, so this one isn't too hard, but there's a little trick there you got to think about. Now, this last one is a lot trickier. The algebra is tricky. Remember, you got a graph of a function, you can easily construct the graph of its inverse. But if you got the algebra, it can get really, really hard. Okay. This is middle of the road part. Don't think anybody completely got it. A couple of people might have. They were on track and I gave them a hint. I think they were going to get it. Okay. So H of X equals, okay, what am I using for B? I use B, and I don't know. Let's say 7X minus 6 over 9X plus 12. Okay, so y equals 7x minus 6 over 9x plus 12. We switch x and y. It always starts out the same. You write whatever the function is, you write y equals that, you switch x and y, and you should really understand why in terms of what we did with the graph. And you get an equation that you can hopefully solve for y. This is a little harder to solve for y. That's a 7, not a 9. Okay. Now, first reflex, you've got a denominator. You multiply both sides by the denominator. So, first of all, you get x times 9y plus 12 equals 7y plus 6 over 9y plus 12 times 9y plus 12 over 1. We put it like that just to remind ourselves that we can then put the 9y plus 12 over here and the 1 over here, and it doesn't change what happens if we multiply the numerators and multiply the denominators. Really try to understand that, because if you don't, you're going to forget. You're likely to forget what to do. Your algebra will be less solid. Just don't do it automatically. Or if you do it automatically, every time you do it, think about why you do that and why it works. Okay, so we do this. I don't cross these out. I just know that I can regroup these, and then I have 9y plus 12 divided by 9y plus 12, which is just 1. We've been over that many times. So I'm just going to write out the 7y plus 6 we get here. We multiply through by the x, we get 9xy plus 12x. Now, some of you didn't multiply the 9y by the x because it didn't look right. Maybe. I'm not sure why. So I'm not necessarily trying to read your mind, but it doesn't look right, so you don't do it. That happens. Okay. Follow the rules. It's x times 9y plus x times 12. So I'm going to write that up. X times 9y plus x times 12. Okay. So you get this, and that's what gives you this. Now, what do you do with this? Okay. So you did something pretty clever, but you didn't quite do the right thing. But you essentially factored out the x here and then divided by the term, and you got back to this and this, which means you got back to where you started from. So it was a good idea, but it took you in a circle. Okay. Now, if you did that, don't feel bad. That was the best attempt I saw without giving hints. Okay. But what you have to do is, we'll put 3 dots down here. If I subtract 7y from both sides, I get a negative 7y over here, and this one goes away. And if I subtract 6 from both sides, subtract 12x from both sides, the 12x goes away here and ends up here. Want you to write out that step though. It's not like we're moving things around. It's like we're following the rules. So when you look at it, you look like, well, I want to move that 12x over here, and I want to move the 7y over here. Okay? You do it by the rules though. Because if the rules don't allow you to move them the way you think you ought to move them, then you can't do it. Okay? And a lot of times, something's going to look like you ought to be able to do it, and you're going to do it, but you really can't. You didn't do it by the rules. Then you missed a problem. Okay? Everything kind of crumbles around you. Okay, so why did we do this? We're trying to solve for y. That's why we want all the y's on this side. So you look at it and you see that. Okay, if I have all the y's on one side, I'm not sure what that's going to do, but I know that I've got to get the variable I'm solving for all on one side. I use the rules and accomplish that. Now what do you do? Well, I can reverse the distributive law and I can write this as y times 9x minus 7 equals 6 minus 12x. Okay, I just reversed the distributive law. I've got a y here and a y here, so I could write this as y times all this. Another way of saying that is I factor out the y. But when you factor out the y, you're just reversing the distributive law. And that's really what almost all factoring is, just a reversal of the distributive law. So you can see it. I've got a y common here, so I ought to be able to do that. I can factor out a common factor. That is a rule. It's really just a restatement of the distributive law, but it's a convenient rule. Okay. So we have this. Well, then we multiply. Sorry. We got this. And then so not F inverse, it's H inverse. And then you can check it. Now, a couple of other things. You can't multiply both sides by 9y plus 12 without changing the equation, unless you're sure that 9y plus 12 isn't equal to 0. So here I'm going to say 9y plus 12 is not equal to 0, so y can't be equal to negative 4/3. So negative 4/3 is not going to be in the domain of this function. You can't get negative. Well, yeah, let me say that. Okay. Down here, you can't divide by 9x minus 7 if 9x minus 7 is 0. Okay. So down here we say, well, x can't equal 7/9. And of course, you can just look at this and see that, well, yeah, your denominator can't be 0, so x better not be 7/9. So you want to be careful about multiplying by 0, dividing by 0. Now, if you do all that algebra and forget about this and this, I'm going to ding you a point, but I'm not going to ding you 10 points. Okay? What a 10-point problem. So if you're looking to make A's, don't get dinged 1 point out of 10. Okay? Because you need 9 points out of 10 to make it. And you should strive for that. Y'all are doing really well. Okay. That's the trickiest algebra you've seen. This isn't particularly tricky, but you got to know it. This is tricky because you got 2 tricky steps. You got to remember to multiply by the denominator. I'm trying to drill that into you. Okay. And then you got to get all your y's on one side and factor y out. So that was a little bit involved, but you can expect to see it on the test. You might or might not, but there's a high probability you will. Okay, so I got mostly good answers, but you know, some of you need to review some basic arithmetic, multiplying by decimals, and stuff like that. You know, have to use a calculator to figure this out. You're missing a piece of arithmetic that you really don't want to be missing. Okay, so 100 minutes. Well, you can say minute charges are $0.02 times 100. And 0.02 times 100, I mean, that's like 2 cents times a minute times 100 minutes is 200 cents, right? Or 0.02 times 100, you know, just what you do with decimals. You get $2. That should be totally obvious. It isn't. You really need to kind of get that in your head. So the total charge is I'm going to use C for your bill. Okay. Is write it out like this. It's per minute charge plus your $12. I was hoping that's what you're going to say. I caught that about the time your hand went up. You alerted me. Okay. Right. So it's what I was going to say, it's your total, it's your per minute charge plus your basic monthly charge, which is $12 a month. So that equals $2. Well, I want to write that 14. Now I get to write it. Okay, makes sense. Okay, well, so we can say, well, how about writing down what's your bill B of T? If T is a number of minutes. See if you can write that. Write me your B of T function. You need to, you can write down what it is if you have 100 minutes, but what is it if you have T minutes? Okay, well, if you think, if you understood what this means, and if you understood this calculation, I think you did, okay? This is what happens if you have 100 minutes. If you have T minutes, well, put a T there, okay? So B of T would be this, okay? Now, usually we won't write the $sign in here, although it's not a bad idea. It kind of clutters things up. We can write B of T equals 0.02 T plus 12. for B of T's in dollars. For T's in minutes. Okay. And we want to be careful about the meanings, and we want to be careful about the units in which we express these things. So we want to be sure we write out a statement like this. You know, unless you got 1,000 problems to do and you're in a hurry, then you want to think the statement. You never want to skip at least the thinking part. And when you're first learning it, you always want to write out all the details. I talked about the Mars probe that crashed into Mars. I don't think I did in here. Wouldn't it come up? Yeah, you know, you're aware that we did the thing where we crashed basically a big chunk of metal with an engine on it into an asteroid yesterday, last night at 7:14. Okay, how many have watched that? Anybody watch it? I thought it was really pretty cool because nobody had ever seen what those asteroids look like until that probe's camera, because they're small. You know, that one asteroid, the smaller one, roughly the size of this building. Okay. That's, you know, a lot of rock in there. It's pretty massive. It's 5 billion tons. So, you know, imagine put a ton of concrete, it's about a cube, maybe this size. Okay. About 150 pounds a square cubic foot. So you would need a little over 10 cubic feet. So you need something a little more than 2 feet, but not quite 3 feet. So you put a ton of concrete, put a couple, 3 tons of concrete under one of these desks. But just imagine a bunch of blocks like this, you lay out 1,000 of them. You got a row of 1,000 blocks. And then you do 1,000 rows. That's 1,000,000. Okay. Then you do 1,000 layers. And pretty soon you've got something that's, yeah, a couple thousand feet by a couple thousand feet by a couple thousand feet. And that's going to be about 1 billion tons. That's 5 billion tons. So, you know, quite a bit of mass. And the rocket is something that, in my prime form, it could have easily lifted. Tree could have lifted. We wanted to run our backs. Okay. And I wasn't, you know, I mean, I was fairly strong, nothing to brag about. So, you know, 4 good sized guys, 3 good sized guys, 2 big guys, that'd be pretty big. I think it weighed about 1,400 pounds, and that'd be 700 pounds each. There are a lot of people that can do that, but most of them are a lot bigger than I am and a lot stronger for their weight. Other than I was anybody stronger than I am now. So that's a pretty neat thing because they're going to be able to, these 2 asteroids are orbiting each other. And they orbit each other in about 11 hours. That's all physics 1. We're going to, but by 1st of November, all my physics students know how to analyze this. Not rocket science. Rocket science is getting the thing there and hitting it dead center, which they did. It was pretty impressive because they weren't able to control it. Controls had to be on it because it takes a couple hours to get the signal there and back. So in the last couple of hours, they had no control. They just got to watch. But I was, you know, I'm sure they had their electronics well honed in their optics. Okay, well, that's just kind of background. They're going to be able to measure the period of that thing over the next couple of days. They'll get a good measurement and see if it changed by as much as they think it should. Because 10-minute change in the period is going to, you know, if they are able to measure the period, which they are, it's going to be easy. Going to be easy to notice that. The other thing is, my calculations, which I've done in my head so far, but I'm pretty sure I've done it a couple of times. I think they're all going to change the speed by a couple of millimeters per second. A couple of millimeters per second is about like this. You barely see it change. Okay, it's going to go that much faster. And it's moving around there. Let's see, 10 kilometers, 60 kilometers. It's going around there at a good walking pace. So include your walking pace by just a couple of millimeters per second. It's pretty neat. And get a 10-minute change in the orbit speed. I haven't worked that out yet. But now that I got the data, I will. Okay, well, that's all pretty easy to work out as long as you keep your units right, as long as you know your masses in kilograms and your forces are in newtons and all that stuff. Okay. Well, they sent this multi-billion-dollar probe to Mars back in the 90s. And they did the last burn, so they go into orbit around Mars, they just crashed right into the planet. Because somebody, instead of putting the mass of fuel in kilograms, they put it in tons. And they weren't using their units. And there was no double check. Somebody put in the data wrong. Billions of dollars and a lot of science was lost. Now, since then we've done even better probes, we still know a lot about Mars. And what that didn't go over real well. My point is, when you do this, you better specify the D's in dollars and T's in minutes. Or that, or put a dollar sign here, put minutes on your T and put minutes in, that way you don't put minutes in your B, it comes out. Okay? Be careful about the units and about what these things mean. Okay. Now, I could draw a graph based on information we have here. I know if T is 0, what's B of T? Show me with your fingers. Now, B of T isn't 0. You still pay a bill even if you don't talk. Yeah, okay, I see it, this 12. Or you could flash all your fingers and then a 2 and just keep. Okay. Okay, so we know that we have the point 0, 12 on this graph. So let's just put a point up here. Oh, this is 0, 12. Now I know what my B scale is. Okay, so I might as well put a scale on it. I got 12 here. If I cut that in half, I've got 6. And then if I add another 6, I've got 18 up here. Okay, now the point is 0, 12. And let me be a little more consistent. Because 0, 12 looked okay when I started. But now 0, 12 is not the same format as just 18 and 6. So let's just put a 12 here. And let's take a different color and label this point. And we'll make that point purple. We still have a little tick mark for 12. Okay. Whatever. Now, you're going to want a better B of T scale because I've got another point to put on the graph. So I'm going to divide each of these intervals in half. Of course, that's going to be 3, and that's going to be 9, that's going to be 15. And then I'm going to divide each of these pretty much equally into thirds, so I know where my units are. More or less. Should do a really good job of that. And now I've got units like 1, 2, 3, 4, 5, 6, 7, 8, 9, and so forth. So what other information do I have? Well, I know that B of 100 is 2, right? I mean, B of 100 is 14. Okay, so where am I going to put 100? I'm going to put 100 about there. So that'd be 200, 300, 400. Maybe if you talk more than 400 minutes, they start giving you a discount or something. I encourage you to talk more. So if we have 100, then everywhere on this line equals 100. Now, how much does it cost? Well, it costs $14, right? So when T is 100, B of T is $14. So 14 is right here. So now I've got another point on the graph. Okay. Now it's obvious that I think that, and maybe not very obvious. The extra amount you pay is directly proportional to how many minutes you talk, right? Well, that means that this graph is going to be a straight line. And if you're not sure it's going to be a straight line, you could let T equal 400. And you get $8.12, and you have the point 400. What? Be up about here. Well, that's going to lie in a straight line. Now, this is not going to be a completely accurate graph, but right there we have it. Okay, so here is the graph of real P. Okay. So I'm going to ask you now, what's the slope of this graph? Okay. We'll ignore the slope for a minute. I'll do that. Okay. Rate of change of B with respect to T is what?
Change of Y and change in T.
The rate of change of Y with respect to X is change in Y divided by change in X. The rate of change of one thing with respect to another is the change in that one thing divided by the change in the other. Okay. So it's not Y and X anymore, but it's okay to think Y and X. But then you think, well, instead of Y, you've got B. Instead of X, you got T. So the rate of change is and I like changing instead of Y2 minus Y1 over X2 minus X1, then you got to make the transition all the way to B2 minus B1 over T2 minus T1. And that can be confusing. If you know what a rate of change is, you don't need that formula. Okay. And that formula is helpful to a lot of people, but you need to move beyond the formula to the idea. The idea is it's a change in one thing divided by a change in the other. Okay. It's delta B over delta T. Okay. Because it's a change of B with respect to T. If it was change in Y with respect to X, it would be delta Y over delta X. But it's change of B with respect to T, so we translate that to change of B over change of T. Okay. Okay, well, kind of out of word space. Let's get into this over here. So we're going to take this and move it all over to this big board. And well, we know B is 12 when T is 0, and B is 14 when T is 100. Calculate a rate of change. You want two values of each quantity. You can't use just one value, you got to use two. Because if you just one quantity, that's not a change. That turns out in this case, that since your T goes from 0 to 100, your change is 100. And that is a value of T, but that's not what you want to think. Because then you're going to make a mistake of using the value of T when the original is 0. Okay. So you want to be careful. It's actually the average rate, but it is the rate in this case. It's a straight line graph. Average rate is delta B over delta T, which equals, I'm going to write it all out, 14 minus 12 over 100 minus 0. That's 2 over 100, which is 0.02. Okay. Now that's the rate. Of course, in the original problem, the rate was $0.02 a minute, or 2 cents per minute. Okay. The units of this are cents or dollars per minute. So it's in dollars divided by minutes. Dollars. $dollars per minute. All right, now connection. What's the slope of this graph? We talked about slope in this class? I don't think we have. Got 2 other classes where I have, so let's make sure. Okay, very good. Very good. So slope is rise over run. Rise divided by run. And everybody's familiar with rise and run. Okay, so slope is rise divided by run. So if we take this graph, we take any 2 points in this graph and find the rise and the run. Well, we've already got 2 points in the graph. Okay. So I can depict that by imposing a triangle on this thing. Here's the rise. This side is the rise, right? Because that's how much higher you got to go to get to this point from this. That's your change in Y, isn't it? Or your change in this case, it's actually delta P. Okay. But it used to delta Y, so I write that in there. The run is delta X, but now T is where X was, so it's delta T. Okay, so if I draw the same triangle, I'll use the same color. this point is 114. This point is 0, 12. So the run is 14 minus 0 equals 14. Rise is 100, not 14 minus 0, which will let me write that. 14 minus 12. Which is 2. And that's not the run, that's the rise. So maybe I have forgotten the equation straight one out of it. Okay. Yeah, I have the minus 0. Your run is this, that's your delta T. Your rise equals 14 minus 12 equals 2, which is your delta P. It's this, and that's the same as the average rate of change. Okay. So you see the average rate of change right there on the graph. Okay, well, just very quickly, something you almost certainly know. So the slope .02, your y-intercept is 12. So the equation is well, y equals mx plus v is your slope intercept form. But here, v equals mt plus v. This is the slope, this is the y-intercept. So b equals 0.02 t plus 12, slope plus y-intercept. So everything is a full circle, and those are all the relationships you really need. The master with open math is going to ask you to do. Okay. You're going to have their explanations, which are good. Make sure you think in terms of meanings.